To call the 2024 Atlantic hurricane season active would be quite the understatement. With 18 named storms, 11 hurricanes, 5 of which would make landfall in the United States, and 5 major hurricanes, it was quite the busy year. And if I could personally describe this year's Atlantic hurricane season with one word, I would say it was surprising. The 2024 season flipped the script on many typical conventions and shattered records in numerous ways. Today, we're going to discuss the 2024 Atlantic hurricane season and take a look at some factors that contributed to some of its biggest and most surprising moments. Afterwards, we'll go over some of the most notable hurricanes of the season and see just what made this season so special. Before we jump into the tropical systems that occurred in 2024, it's important to talk about the expectations that were set for this hurricane season. Well before hurricane season even started, there was talk of this year being well above average. Many major meteorological agencies, such as NOAA and Colorado State University, set fairly high expectations for this season. Colorado State's first forecast was issued on April 4th, predicting 23 named storms, 11 hurricanes, and 5 major hurricanes. NOAA's first hurricane season forecast was made on May 23rd, where they forecast anywhere from 17 to 25 named systems, 8 to 13 hurricanes, and 4 to 7 major hurricanes. For context, the past 30-year average for the Atlantic hurricane season, as defined by NOAA and Colorado State, has been 14 named storms, 7 hurricanes, and 3 major hurricanes. Both NOAA and Colorado State University would tweak their forecasts slightly as the season progressed, but stayed relatively in line with their initial predictions. Other meteorological universities, such as North Carolina State University, the University of Arizona, and the University of Missouri, all predicted an above-average hurricane season, with all 3 categories previously mentioned forecasted to be above average. The most, and I hate to say it, insane prediction came from the University of Pennsylvania. On April 24th, they released a prediction of 33 named storms, with the potential for that number to be as low as 27 or as high as 39. If that would have come to fruition, it would have been a truly unprecedented season, as the record for named storms was set in 2020 with a total of 30. So you may be wondering, how do all these meteorological agencies and universities make these forecasts? What factors go into predicting the activity of a hurricane season so early in advance of a season? Let's get into that now. A multitude of factors go into predicting how the Atlantic hurricane season will play out in any given year. Generally speaking though, 3 primary factors tend to stand out. 1. How warm is the ocean and the temperature of the sea surface across the basin? 2. Is the hurricane season going to take place during a La Nina, an El Nino, or a neutral year? And 3. How strong is wind shear over the basin? Let's break each down point by point. To start, arguably the most important factor is sea surface temperatures. Tropical cyclones get their energy primarily from the heat stored within the ocean due to sunlight hitting the earth. Water absorbs much more heat energy than land and tends to retain that energy for much longer. Simply put, the warmer the ocean temperatures, the more likely that tropical cyclones will develop and strengthen into tropical depressions, tropical storms, or hurricanes. In terms of the 2024 season, record high sea surface temperatures were reported across much of the Atlantic Ocean, and especially in the southern Caribbean and Gulf of Mexico. Tropical cyclones tend to only form in areas where the sea surface temperatures are over 79 degrees Fahrenheit, so cooler ocean temperatures can actually hinder tropical development. Next up, we have the ENSO, otherwise known as the El Nino and the Southern Oscillation. This is a bit of a complicated topic that frankly I'm not qualified to talk about in depth, so I will leave some further reading from NOAA in the description if you would like to learn more. But for the sake of this video, I'm going to try and describe it in the most simple way possible. To put it simply, the ENSO describes periods of fluctuation in sea surface temperatures and atmospheric pressure over the Pacific Ocean. This can have major effects on not just the Pacific hurricane season, but the Atlantic hurricane season as well. When the ENSO is in an El Nino phase, sea surface temperatures in the eastern equatorial Pacific are warmer than average. This leads to above average wind shear in the Caribbean, along with causing more sinking motion within the atmosphere, leading to generally more atmospheric stability. This tends to somewhat dampen hurricane activity in the Atlantic basin, but active years could still occur during El Nino. For example, 2023 was still an above-average hurricane season despite the Pacific being in the El Nino stage of ENSO. Conversely, we have La Nina. La Nina occurs when temperatures in the equatorial Pacific are cooler than average, which causes a multitude of changes within the atmosphere. The main impact of La Nina is that it causes significantly reduced vertical wind shear across the Caribbean, which helps hurricanes develop with little interruption. There also tends to be more rising motion in the atmosphere over the Caribbean and southern Atlantic, which translates to more atmospheric instability. This helps lead to the development of showers and thunderstorms, which are the predecessors to tropical cyclones. La Nina years tend to be very active for the Atlantic basin, with 6 out of 10 of the most active seasons on record occurring during La Nina years. In 2024, many meteorological institutions predicted that we would be entering a La Nina by fall of 2024. However, that did not come to fruition by the end of the season. Lastly, let's talk about wind shear. Wind shear simply describes the change in direction of wind with height. Wind shear is associated strongly with the ENSO cycle, but also occurs all the time in relation to other types of weather patterns over the United States and all around the world. You may already know that wind shear is an essential ingredient in developing severe thunderstorms and tornadoes even over the continental United States. So if they're beneficial to the strengthening of thunderstorms on land, why does wind shear impact hurricanes so negatively? Tropical cyclones like structure, and they can be very sensitive systems. By that, I mean any interruption to their overall structure can have drastic effects on the stability of the storm. Generally speaking, for a tropical cyclone to strengthen, they need to have a strong core of tall thunderstorms rotating around their low-pressure centers. Hurricanes are at their strongest when they are symmetrical, with little change in the direction of wind with height to offset the tops of thunderstorms and the transport of heat and moisture into the system. When a tropical cyclone goes through an area of intense wind shear, this often leads to the storm becoming lopsided, which can allow for the intrusion of dry air, among other things. A great example of wind shear impacting a hurricane was that of Hurricane Marco in 2020. Strong wind shear over the Gulf of Mexico not only helped inhibit it from strengthening further, but would go on to essentially tear the storm apart before it even made it to land. The amount and intensity of tropical cyclones in the Atlantic basin can be affected by more than just these three factors, such as Saharan dust that comes off the coast of Africa, or even the monsoon season in Africa. Frontal systems that tend to cross the U.S. later in the season can also help or hinder the development and tracks of tropical cyclones. But the previous three aforementioned factors are the primary drivers behind the level of activity and intensity of the Atlantic hurricane season. Now that we have an understanding as to what meteorological factors lead to active hurricane seasons, we can finally discuss the 2024 Atlantic hurricane season itself and all of its oddities. I will not be covering every single named storm, as like most seasons, quite a few of the tropical cyclones that formed did not directly impact land. People like to call these fish storms. In addition to that, there were numerous low-end tropical storms that did make landfall, but frankly, compared to what we're going to go over today, did not make nearly as much of a splash. That is not to discredit their impact, it's just we already have a lot to go over today. However, quite a few powerful tropical cyclones did make landfall this year, and not just in the United States. Well, let's get into some of the most notable storms, going in chronological order throughout the season. To start off the list, we have Hurricane Beryl. Beryl formed from a tropical wave in the central tropical Atlantic as it drifted westward towards the outer eastern islands of the Caribbean in late June. Beryl was first named as it developed into a tropical storm on the evening of June 28th, a few hundred miles east of the Windward Islands. By the evening of June 29th, Beryl had intensified into the season's first hurricane. With extremely warm sea surface temperatures beneath it and little in the way of wind shear, Beryl would go on to rapidly intensify into a major hurricane. From 5 p.m. on June 29th to 5 p.m. on the 30th, Beryl would double its maximum wind speed from 75 to 130 miles per hour. The storm would fluctuate slightly in strength as it approached its future landfall location on the island of Grenada. At around 11 a.m. local time on July 1st, Beryl would make landfall near Caraco as an extremely powerful Category 4 hurricane with sustained winds of 140 miles per hour. Shortly after passing through the Windward Islands, Beryl would give us our first major surprise of the hurricane season. On the evening of July 1st, Beryl became a Category 5 with sustained winds of 160 miles per hour. This is the earliest on record that a tropical cyclone has reached Category 5 status in the Atlantic Basin. Beryl would continue to chug along through the Caribbean, eventually weakening back down to a Category 4. Beryl would just barely miss direct landfall in Jamaica as an extremely intense Category 4 on July 3rd. The storm continued to work its way westward across the Caribbean, weakening into a still powerful high-end Category 2 hurricane by the time of its next landfall on the Yucatan Peninsula of Mexico on the morning of July 5th. Beryl weakened into a tropical storm over the Yucatan and remained as such over much of its trek through the western Gulf of Mexico. Despite this, Beryl managed to re-strengthen into a Category 1 hurricane right before its final landfall near Matagorda, Texas, early in the morning of July 8th. Beryl would then rapidly weaken as it made landfall, transitioning into a post-tropical cyclone thereafter. Despite this, the storm would still have a devastating impact across the United States. Beryl claimed the lives of 42 people in Texas alone and spurred a massive tornado outbreak from Louisiana all the way up to New York. From start to finish, Beryl was a shocker of a storm and a warning shot for the 2024 hurricane season. For our next storm, we have the start of Florida's streak of bad luck with hurricanes in 2024, Hurricane Debby. The predecessor tropical wave that would become Debby formed east of the Windward Islands towards the end of July. The system would slowly drift its way west-northwestward, being designated Potential Tropical Cyclone 4 by the National Hurricane Center on August 2nd. A storm is designated a potential tropical cyclone when the National Hurricane Center expects a tropical cyclone to develop, but it does not currently possess the characteristics to be classified as such. This is usually only done if the storm is close to or currently impacting land, as a means to issue advisories and tropical weather alerts even if the storm hasn't technically formed yet. 12 hours after the initial designation of PTC-4, the future Debby would develop a closed low-level circulation, officially allowing it to be designated as Tropical Depression 4. The depression would continue to work its way over Cuba through the day on August 3rd, before developing into Tropical Storm Debby on the evening of August 3rd, around 70 miles to the northwest of Cuba. At this point, the storm was forecast to move its way up into the Florida Panhandle or Big Bend, and was expected to develop into a hurricane before landfall. Debby remained a tropical storm for much of its trek towards its first U.S. landfall in Florida, before developing into a Category 1 hurricane late on the night of August 4th. As noted in Advisory 11, the one where Debby was designated a hurricane, the storm was expected to slow down, setting the stage for a heavy rainfall event across northeast Florida and southeastern Georgia. Debby would make her first U.S. landfall on the morning of August 5th at around 7 a.m. near the town of Steinhatchee, Florida, with maximum sustained winds of 80 miles per hour. Debby would slowly churn its way across the deep south as a now tropical storm, dropping torrential rainfall across much of the Florida Big Bend, northeastern Florida, and southeastern Georgia. By 11 a.m. on August 6th, Debby was back out over the Atlantic waters, slowly meandering around as a tropical storm. It would take all the way until the morning of August 8th for Tropical Storm Debby to make its second landfall near Bulls Bay in South Carolina, with sustained winds of 50 miles per hour. Debby would continue to work her way over the southeast before weakening into a tropical depression and then a post-tropical cyclone. From there, the system would accelerate northward, affecting much of the U.S. eastern seaboard and even parts of Canada. The most notable impact to come from Debby was the rainfall. Across Florida, Georgia, and the Carolinas, numerous locations would see upwards of a foot to a foot and a half of rain, with the highest rainfall total being reported from Parrish, Florida. Here, nearly 19 inches of rain fell. Interestingly, Parrish is located in southwestern Florida, far from the initial point of landfall. This just goes to show that significant impacts often can and do occur far from the center of the storm or even from the point of landfall. Speaking of which, Debby would even go on to cause historic flooding in Quebec, all the way up in Canada. There, 157 millimeters, or around 6.18 inches of rain, fell in one day. While that is notably less than what occurred down in the southern US, that is still substantial rainfall, and was the city's highest one-day rainfall total it had ever seen. As of October 2024, Debby is estimated to have caused $7 billion in damages across the United States, with another $2.5 billion done in Canadian dollars. Despite being one of the relatively weaker storms of the 2024 season, Debby was still absolutely devastating to so many people. Unfortunately, Debby was only the start of an onslaught of tropical cyclones that would affect the U.S. later in the season. The next U.S. landfalling hurricane of the season struggled to get its act together for a majority of its life, but managed to become a strong Category 2 hurricane before making landfall in the Gulf of Mexico. That would be Hurricane Francine, and her story starts all the way back on August 26th. The National Hurricane Center designated an area in the central Atlantic for potential development, and a tropical wave did indeed form. This tropical wave would have trouble organizing for well over a week as it continued to drift across the southern Caribbean. After crossing over the Yucatan Peninsula of Mexico and into the Bay of Campeche, which is an area of the southwestern Gulf, the wave would finally develop into a low-pressure system on September 8th. The system was given its first advisory at 4 p.m. on September 8th and designated Potential Tropical Cyclone 6. The first cone forecast had it gradually strengthening into a hurricane before making landfall somewhere along the western Gulf of Mexico. As you can see by the projected tropical storm force wind field in orange, the system was still incredibly lopsided and disorganized, with most of the wind occurring on the western side of the circulation. By 10 a.m. on the morning of September 9th, PTC-6 fully developed into Tropical Storm Francine, with sustained winds of 50 miles per hour. The storm was now forecast to make a landfall as a hurricane somewhere along the Louisiana coastline, with the circulation and wind field slowly becoming more well-defined and organized. Francine would continue to strengthen on its approach to Louisiana, becoming a hurricane on the evening of September 10th. Francine would undergo rapid intensification as well throughout its trek to Louisiana, increasing its maximum sustained wind speed by 35 miles per hour in 24 hours. Peaking at 100 mile per hour sustained winds, Francine made landfall at Category 2 intensity in Terrebonne Parish on the evening of September 11th. Francine would then go on to weaken quickly, weakening into a tropical depression by the time it exited Louisiana on the morning of September 12th. Thankfully, not a single fatality was reported as a result of Francine. In a similar fashion to Debby, the most notable impact from Francine was the rainfall. Many areas across southeastern Louisiana saw rainfall ranging from 6 to 10 inches. However, the highest rainfall total reported from Francine would actually occur in the Florida Panhandle, near Lanark Village. Here, just over a foot of rain fell. Notable amounts of rain also occurred in the states of Mississippi, Texas, Tennessee, and Arkansas. As of now, damage estimates from Hurricane Francine are upwards of $1.5 billion. Before we get into our next hurricane, there's another interesting aspect of the 2024 hurricane season I want to briefly touch on, and it actually has to do with the lack of activity. Historically, the peak of the Atlantic hurricane season occurs in early to mid-September. Date-wise, the peak of hurricane season is considered to be on September 10th, with activity slowly dwindling as the season wears on. However, this season was quite backloaded, with multiple devastating storms happening weeks and up to 2 months after this historical peak, but I'm getting a bit ahead of myself. By early September, some news outlets and publications were quick to call the 2024 hurricane season slow, or even say it was underperforming, which by historical standards may have been accurate, but I personally feel this phenomenon was not framed well by some outlets. I don't want to go too far into it, as I think a topic like this deserves an entire other video, but people often cling on to headlines like this and use it as an excuse to spread misinformation, cast doubt on our scientific institutions, and instill fear in the general public. This can range to relatively mild cases, such as random people online making early calls about a season being a disappointment, leading to the uninformed to let their guards down, all the way up to average people, and sometimes even government officials, peddling conspiracy theories about the government creating hurricanes or controlling hurricanes to make their forecasts look better, or in order to interfere with a presidential election. Regardless of my feelings on some journalists and people jumping the gun on this season, there was in fact a notable mid-season lull in activity. Was there a reason behind this lack of activity? While there isn't one single factor that led to this lull, a handful of atmospheric conditions likely contributed to the quiet spell of tropical activity. Unfortunately, as of the time of writing this script in December, there doesn't seem to be any articles or publications on the phenomenon from the National Hurricane Center or NOAA, so for answers, we'll have to look to other sources of meteorological information. For that, we will consult this mid-season discussion from Colorado State University, which will be linked in the description down below if you'd like to do some further reading. For now, we'll just cover the basics so we can get back to discussing the extremely active second half of the hurricane season. According to Colorado State University, it seems that 4 primary factors played into the lack of activity through August and into the first half of September. 1. There was a shift in the typical path of the African monsoon season, which has been sending potential tropical waves into more unfavorable parts of the Atlantic Ocean. 2. The upper atmosphere has been extremely warm over much of the eastern Atlantic, leading to increased atmospheric stability. 3. Too much easterly wind shear in the eastern Atlantic. And lastly, 4. An unseasonable variation in the Madden-Julian oscillation. Let's once again break down all of these factors one by one in order to understand how these conditions affected the hurricane season. For starters, we have to look at the African monsoon season. A monsoon is described as a seasonal change in the direction of atmospheric winds which helps bring in moisture and helps fuel the development of showers and thunderstorms. During the summer months in northern Africa, these waves of showers and storms tend to roll across the continent and out into the eastern Atlantic, which then have the chance to develop into tropical cyclones. However, in 2024, the typical surface trough, or region of lower atmospheric pressure, that helps guide these disturbances shifted much further north than usual. This resulted in many of these areas of disturbed weather emerging in cooler areas of the Atlantic, which, as we have discussed earlier in the video, can inhibit the development of tropical cyclones. Secondly, we have considerably warmer temperatures in the upper atmosphere. While sea surface temperatures and the overall heat content of the ocean have been extremely conducive for tropical development over much of the Atlantic, upper-level atmospheric temperatures have also been much warmer than average. Warmer temperatures in the upper reaches of the atmosphere provide a stabilizing effect, which can help inhibit the development of deeper convection. Basically, showers and thunderstorms can still form, but they may have a hard time becoming more robust. Third, there's been too much easterly wind shear over the eastern Atlantic waters. Throughout August of 2024, much of the Atlantic Basin saw anomalies in the levels of easterly wind shear over much of the Atlantic Basin, including the main development region. According to Colorado State, these anomalies had a lesser effect on the western and central Atlantic while having a more pronounced effect on the eastern Atlantic. As mentioned earlier when discussing wind shear, this can be detrimental to the formation of high-top convection around the centers of what would be tropical cyclones. High wind shear likely had a large impact on the African easterly waves, shredding many of them before they even had a chance to develop into tropical cyclones. Lastly, we have unfavorable conditions related to the Madden-Julian oscillation. The MJO is another topic that I don't really feel that qualified to talk about in detail, so I'll leave an article from NOAA in the description if you would like to read further. However, I will still explain the bare basics for the sake of understanding how this system impacts the hurricane season. The Madden-Julian oscillation is a similar type of atmospheric process to the ENSO. According to NOAA, the MJO is a disturbance consisting of clouds, rainfall, winds, and pressure changes that travels across the whole planet every 30 to 60 days. The MJO primarily falls along the mid-latitudes, generally near the equator and tropical regions of the Earth. The MJO has wide-reaching effects all across the planet, such as altering the timing of monsoonal seasons, the ability to increase or decrease the intensity and number of tropical cyclones in any given tropical ocean basin on Earth, and can even change the path of the jet stream over North America, which can often lead to extreme cold snaps or heat waves, as well as contributing to severe weather outbreaks. When it came to the 2024 hurricane season, the MJO was over much of the Atlantic during the month of August, helping to increase vertical wind shear in relation to a trough of pressure that was over the central Atlantic. Again, vertical wind shear tends to inhibit the development of tropical cyclones. To conclude this section, a variety of factors big and small contributed to the sharp decrease in tropical activity between August and the first half of September. Noticeably, all these factors seem to have the biggest impact on the central and eastern Atlantic, as not many storms formed out there this year. The ones that did tended to be fish storms and did not cause nearly as many impacts to life and property as the ones that formed over the western Atlantic, the Caribbean, and the Gulf of Mexico. Even the tropical waves that did manage to make it from the eastern Atlantic and towards the US tended to have a lot of trouble developing into strong systems, despite the extremely warm ocean waters, with Beryl being the main exception to that rule. Despite the mid-season lull in activity, I think we all know what would come after this period. After getting through a quiet peak season, the Atlantic Basin roared back to life in the second half of September. This included 3 different fish storms forming in the last 5 days of September, those being Isaac, Joyce, and Kirk. But the most notable storm of this period and the most devastating hurricane of the 2024 hurricane season was given its first advisory on September 23rd. This system would go on to be known as Hurricane Helene and would cause widespread devastation from Florida all the way to Virginia. At 11 a.m. on September 23rd, a broad area of low pressure over the western Caribbean was designated Potential Tropical Cyclone 9. From its first advisory, PTC 9 was forecast to make landfall along the Florida Panhandle or Big Bend region as a hurricane within the next 5 days. 24 hours later, PTC 9 developed tropical characteristics and was named Tropical Storm Helene, with maximum sustained winds estimated to be at 45 miles per hour. Helene would continue to intensify as it lurched towards the U.S. Gulf Coast, first becoming a hurricane at 10 a.m. on September 25th. Starting early in the morning of September 26th, Helene would begin to undergo rapid intensification, with the strengthening trend maintaining all the way to landfall. Within 22 hours, Helene would go from an 85 mile per hour Category 1 hurricane to a monstrous 140 mile per hour Category 4 hurricane, making a jump of 55 miles per hour in sustained winds. Helene made landfall at around 11:20 p.m. on the evening of September 26th in the Big Bend of Florida at peak intensity. Despite making landfall in Florida, arguably the worst Helene had to offer would extend much further into the deep south, heavily impacting areas of western North Carolina and eastern Tennessee. The saving grace for Florida was just how fast Helene was moving. Helene was absolutely hauling its way to the north, hitting a forward movement speed of 26 miles per hour. Helene would hit a maximum forward movement speed of 32 miles per hour per the 11 a.m. advisory on September 27th. The movement speed of Helene was a major contributor to just how devastating this hurricane was. Hurricane-force winds tore through not just the Florida Panhandle, but a large majority of southern Georgia and into the western portion of the Carolinas. This is extremely unusual for hurricanes that make landfall in Florida and then move north through the rest of the South. However, for as impressive and devastating as the winds from Helene were, that was not the primary impact. That would have to go to the absolutely historic rainfall produced by this hurricane in the southern Appalachian Mountains. I do not have words to describe the levels of devastation that occurred in North Carolina due to the rainfall. Entire rural mountain towns were ripped from the face of the earth, along with miles and miles of trees and mountainside. This devastating amount of rainfall was only compounding on an already bad situation, because a few days prior to Hurricane Helene's rampage across the South, there was what is known as a predecessor rain event, or a PRE. Due to a variety of meteorological factors depicted on screen, extreme amounts of moisture were funneled into northern Florida, Georgia, and especially the Carolinas well in advance of the main area of rain associated with Helene. When all was said and done, widespread rain totals of 1 to 2 feet spread from Florida all the way up to Virginia. The worst of the rain would impact western North Carolina though, with some areas receiving upwards of 30 inches. These may not even be the true highest totals due to the sheer devastation caused by the storm. As of now, the death count from Helene stands at a staggering 234 people, making it the deadliest United States landfalling hurricane since Katrina in 2005. On top of that, the economic damage was equally as devastating, currently estimated to reach upwards of $120 billion. This makes Helene the third costliest hurricane in U.S. history, only topped by Katrina and Harvey. Hurricane Helene was such a wide-reaching and a devastating storm, there is not a chance in hell I could do it full justice in this video. However, out of all the hurricanes that occurred in 2024, I think Helene will be the one that is remembered the most for generations to come. For all the carnage that Hurricane Helene caused, it was still not the strongest hurricane that 2024 had to offer, and no, that distinction does not go to Beryl either. That honor, if you can even call it that, would go to our next storm on the list, Hurricane Milton. The last of a terrible trio of hurricanes to impact Florida in 2024, the last U.S. landfalling hurricane of the season would be quite the spectacle, both while it was out over the open waters of the Gulf of Mexico, and especially once it made impact on the Florida Peninsula. Starting on September 26th, the National Hurricane Center began monitoring an area in the Caribbean for the potential of tropical development. Notice this was during an already active period, with Helene approaching Florida, Isaac churning away in the northern Atlantic, and soon to be Joyce getting ready to develop. Over the next few days, a broad area of low pressure would develop, but was not able to hold itself together. While the National Hurricane Center was still keeping an eye on this area, the circulation had broken down into an open low-pressure trough, producing extremely disorganized showers and thunderstorms. However, after a few more days of drifting around in the Gulf, and with the help of both a stationary front and remnants of a Pacific tropical depression, the low-pressure center that would soon become Milton managed to become better organized. By the evening of October 4th, confidence became much higher that a tropical cyclone would form out of this area of disorganized weather. Finally, on the morning of October 5th, the low pressure would be designated Tropical Depression 14 and would be given its first advisory and forecast graphics. Even from the first advisory, the 5-day forecast cone depicted a hurricane making impact somewhere along the western coast of Florida. This graphic is actually the first surprise that the future Milton would provide us. While not unheard of, it's pretty rare for a tropical cyclone to form in the western Gulf of Mexico and make it all the way to landfall on the west coast of Florida. Typically, if a tropical cyclone impacts Florida's western side, it comes up from the south, usually out of the Caribbean, and then curves back inwards towards Florida, such as with 2023's Hurricane Idalia for the Big Bend, or 2022's Hurricane Ian for southwestern Florida. Over the next 24 hours, Milton would slowly drift its way eastwards through the Gulf, not being steered all too much due to weak steering flow in the atmosphere. Notably, the west coast of Florida was now within the 3-day cone, with Milton forecast to be at least a Category 3 major hurricane on landfall. By 1 p.m. on October 6th, Milton had officially become a hurricane with sustained winds of 80 miles per hour. This was only the beginning of Milton's strengthening, however, as it would soon explode into one of the most monstrous hurricanes the Gulf of Mexico had ever seen. 6 hours after Milton became a hurricane, a period of rapid intensification would begin to occur. This has been all too common in the 2024 season, but what Milton did was something else entirely compared to the other storms we've discussed so far. From 7 p.m. on the 6th to 7 p.m. on the 7th, Milton would explode from an 85 mile per hour Category 1 to a monstrous 180 mile per hour Category 5, with a minimum central pressure of 897 millibars. That's a jump in wind speed of 95 miles per hour in only one day. And about that minimum central pressure, that puts Milton comfortably as the 5th most intense Atlantic hurricane on record. It's been nearly 2 decades since we've seen Atlantic hurricanes that intense, with Rita and Wilma in 2005 hitting 895 and 882 respectively. However, also noted in this advisory from the National Hurricane Center, Milton would soon undergo an eyewall replacement cycle. An ERC is a phenomenon that occurs in hurricanes, typically the major ones, so Category 3 or higher. In intense hurricanes such as Milton, sometimes 2 different eyewalls can form. The secondary outer eyewall begins to close inwards towards the center, which can weaken the primary central eyewall due to the two having to share moisture and the momentum of the main eyewall being thrown off. Typically, an eyewall replacement cycle will temporarily weaken a hurricane, but if conditions remain favorable, which they did for Milton, the storm will likely re-intensify. Milton began to weaken slightly, becoming a high-end Category 4 by 1 a.m. on the morning of October 8th. However, by 4 p.m. that afternoon, Milton managed to recover his strength, making a second run at Category 5, with this round having a peak maximum sustained wind speed of 165 miles per hour and a minimum central pressure of 902 millibars. With Milton being roughly 25 hours from landfall, it looked like it was going to be a worst-case scenario situation for western Florida, but if you could believe it, Lady Luck actually cut our state a little bit of slack for once in 2024. As Milton began its final approach towards Florida, strong southwesterly wind shear began to take over, causing the hurricane to weaken rapidly. When I say weakening here, that is still relative, as Milton would still make landfall as a powerful Category 3 hurricane with maximum sustained winds of 120 miles per hour near Siesta Key. But I'm sure everyone that lives in Central Florida would agree that's much more preferable to a 180 mile per hour Category 5 hurricane making landfall. The effect of wind shear on Milton is clearly evident on satellite imagery, as the hurricane lost much of its symmetrical structure leading up to and upon landfall. Also not helping the hurricane was a nearby stationary frontal boundary, which likely had an impact on its organization. Despite Milton's weakening trend, that did not stop the hurricane from being absolutely devastating to much of Central Florida. What set Milton apart from the other hurricanes we discussed so far may actually be what occurred in the lead up to the hurricane's landfall, and that would be the historic tornado outbreak it spawned. It's not uncommon for tornadoes to be spun up in the outer rain bands of a hurricane, or even isolated cells that thrive in the sheared environment a landfalling hurricane causes, but Milton's outbreak was much more than just a few tornadoes. In total, Milton would spur the issuance of 126 tornado warnings in Florida, which is the second most from a state in one day in U.S. history. For context, the only other day that tops this is April 27, 2011 in Alabama. This was during the peak of the 2011 super tornado outbreak, so it's needless to say this event was pretty unprecedented. In terms of the actual confirmed number of tornadoes, that would be 47 at the time of writing. This absolutely crushed Florida's previous one-day record, which was 15 tornadoes during the February 1998 Kissimmee outbreak. Tying this record in 2017 was another 15 tornadoes spawned by Hurricane Irma, but again, Milton destroys those previous two records by triple the amount. Aside from the sheer number of tornadoes that spawned, another notable aspect of this tornado outbreak was the intensity and the size of some of these tornadoes. Before we even discuss ratings, some of the videos that came from Milton are downright insane. These wedge-like tornadoes are the types of things you'd expect to see out of Oklahoma or Kansas, not Florida. In regards to intensity, however, 3 different EF3 tornadoes would impact southern Florida, with the strongest being an EF3 with estimated peak winds of 155 miles per hour. Also of note was an extremely long-tracked EF2 tornado that went right through Port St. Lucie, which was on the ground for almost 32 miles. This tornado outbreak could fill in a whole video, and I do plan on talking about some of these tornadoes in more detail in a future video, but seeing how long this one already is, I'm keeping it brief because we still have more to go. Maximum sustained winds from Milton itself, and not the tornadoes, were fairly intense along coastal regions as well. According to the Florida Climate Center, the highest sustained wind gust was reported at the Tampa Skyway Fishing Pier, hitting 103 miles per hour. A few other areas saw wind gusts exceeding 100 miles per hour, but there were no reports of wind speeds reaching the estimated 120 miles per hour that Milton was reported to be at landfall. Heavy rainfall was also another big player in Milton, with some areas seeing over 1.5 feet of rain in just one day. Overall, Milton was arguably the most diverse hurricane we saw in 2024. From spurring a historic tornado outbreak, dumping well over 1 foot of rain in multiple areas, and lashing the coast with winds in excess of 100 miles per hour, it's easy to say that Milton will be remembered by Floridians for a very long time. To me, the craziest part of this event is just how devastating it was, in spite of how much worse it could have been. Remember, Milton was still a beast of a Category 5 hurricane just a day before landfall. If it wasn't for the storm being heavily sheared, these impacts could have been significantly worse. I am extremely thankful, though, that despite the devastation Milton did end up causing, the worst case scenario did not play out. But, in spite of that, the storm still caused an estimated $85 billion in damages and tragically took the lives of nearly 36 people, with 32 of those fatalities occurring in Florida alone. Let's take a break from monstrous major hurricanes, shall we? While Milton was still on its approach to Florida on October 8th, the National Hurricane Center was watching a tropical wave over Western Africa. As mentioned in an earlier portion of the video, many of the tropical waves to come off of Africa this season were not particularly robust. However, one small wave managed to defy the odds and cross much of the Atlantic, becoming a hurricane in the Caribbean. This wave would make it off the coast of Africa and into the Atlantic on the evening of October 10th, where satellite data indicated that the storm had estimated winds of 30 to 35 miles per hour. Even this early on, the National Hurricane Center predicted that the low pressure's chances of forming were not particularly high, as upper level conditions would become less favorable as it moved westward across the Atlantic. By October 11th, they gave the system a 50% chance of forming, but odds would fall soon after. After a few more days, the system would once again be given a higher chance of forming, this time at 60%, while it was over the central Atlantic. However, confidence would once again drop down all the way to 30% by the morning of October 17th. By the morning of October 19th, the low-pressure system that would become Hurricane Oscar was still only given a 30% chance of forming while it was positioned to the north of the island of Hispaniola. It even says in this outlook that development was not expected. However, just 3 hours later, development chances doubled, jumping up to 60%. In just a few short hours, the little hurricane that could was about to stun the National Hurricane Center and forecasters everywhere. At 11 a.m. on October 19th, Tropical Storm Oscar was designated, with estimated sustained winds being at 40 miles per hour. Once again, the National Hurricane Center doubted Oscar, stating that little change in intensity was forecast. Oh boy, were they wrong. By 1 p.m. on the 19th, hurricane hunters found that Oscar was actually quite a bit stronger than anticipated, having peak sustained winds of 70 miles per hour, just shy of being a Category 1 hurricane. By the 2 p.m. advisory, Oscar had officially become a Category 1 hurricane with sustained winds of 80 miles per hour. Mind you, with a jump of 40 miles per hour, this still counts as rapid intensification. Also noted in this advisory was just how tiny Oscar was. Per this advisory, Oscar had hurricane force winds only extending out 5 miles from its center, with tropical storm force winds extending out 45 miles. This was yet another record breaker of a hurricane, albeit in a much less severe way compared to some of the other ones we've discussed in this video. With a hurricane force wind field of only 5 miles, Oscar was the smallest hurricane in recorded history. Oscar would reach peak intensity on the evening of October 19th, reaching 85 miles per hour sustained winds with a minimum pressure of 987 millibars. The hurricane made landfall near the town of Baracoa in northeastern Cuba on the evening of October 20th, with maximum sustained winds of 80 miles per hour. By this time, the hurricane force wind field expanded to be about 10 miles. Oscar quickly weakened to tropical storm strength after landfall and would continue to drift northeastward through the Bahamas as a low-end tropical storm before dissipating on October 22nd. Despite Oscar's small size, the storm was no slouch. The hurricane managed to drop at least 10 inches of rain within the province of Guantanamo, according to the National Hurricane Center. Homes were reported to have received damage, especially along the coast due to high waves. Unfortunately, 6 deaths were reported as a result of this hurricane. But all of this begs the question, how exactly were National Hurricane Center forecasters so off the mark when it came to Oscar? How does a storm with a 30% chance of developing become a Category 1 hurricane in a matter of hours? Much of that is down to the incredibly small size of Oscar. Remember, the storm only had a hurricane-force wind field of 5 miles upon its designation. That, combined with the storm being positioned in a part of the world with less meteorological equipment directly on the ground, made it incredibly difficult to estimate its strength from up close. That duty was mostly left up to satellites and computer models, both of which have trouble making estimates on such small-scale systems. And remember, Oscar was only designated a hurricane after hurricane hunters flew into the storm and dropped off a drop sonde. This helped forecasters get direct data on the storm, which made the picture much clearer. Some compared Oscar to a thunderstorm cluster, the kind of which you might see over the United States on a hot summer day. Granted, one that's a lot more tightly wound and fully rotating. And when you look at it that way, it's pretty easy to see why the forecasting was so tricky on this hurricane. Oscar was quite the shocker to everyone, including hurricane forecasters. This is just another reminder that even small storms can be devastating, and every tropical system should be taken equally as seriously. For our last hurricane we're going to cover today, we will once again shift our focus away from the United States and down into the Caribbean and parts of the Gulf of Mexico. Our last tropical cyclone was a late season surprise, occurring in early November and impacting the island of Cuba. This hurricane is Rafael, and before we go into more detail about it, I want to briefly discuss late season hurricane climatology. When it comes to hurricanes in November, the main areas we see them occur in are the far southern Caribbean, typically off the eastern shores of Central America, and to the south of islands like Cuba, Jamaica, and Hispaniola. It is much less common to see tropical cyclones survive in the Gulf of Mexico, or really anywhere else in the Atlantic this far into hurricane season. This is mostly due to sea surface temperatures beginning to cool off, especially in areas closer to home in the United States as frontal systems begin to pass. Here's a map from NOAA plotting all Atlantic tropical cyclones that reach hurricane strength in the month of November. Notably, you see that many of these systems originate in the Caribbean, off the southeastern coast of the United States, and occasionally in the far western Atlantic. Narrowing down the search to just hurricanes that reached major status, or Category 3 or higher, it's clear to see that most of the major hurricanes focus heavily in the southern Caribbean. Again, this is where the sea surface temperatures remain the warmest during the later parts of the year. And despite being so late into hurricane season, some of these storms aren't slouches. A Category 5 hurricane occurred in this part of the basin in 1932, the only one to happen in November, though it made landfall at Category 4 intensity in Cuba. Back in 2020, the double trouble combination of Eta and Iota made landfall only 2 weeks apart, within 15 miles of each other on the east coast of Nicaragua, and both at Category 4 strength. Lenny was a very strange Category 4 hurricane in 1999 that traveled from west to east across the basin, impacting portions of the U.S. Virgin Islands. While hurricanes occurring in the Caribbean during November is somewhat common, what isn't common is hurricanes occurring in the Gulf of Mexico during this time of year. On record, there have only been 7 hurricanes in the Gulf of Mexico during the month of November. All but one of those, that being one in 1985, formed outside of the Gulf and then worked their way into the region. One also was a hurricane on October 29th, weakening to tropical storm strength after landfall, and dissipated on November 1st, so that doesn't technically count if we're talking about November Gulf hurricanes. If we narrow this search down to just major hurricanes, there's only been one in the Gulf across recorded history, and that would be Kate in 1985. Kate briefly intensified to Category 3 over the Gulf, but would ultimately make landfall as a Category 2 in the Florida Panhandle. So, what does all of this have to do with Hurricane Rafael? Well, let's get to him now. Our first signs of Rafael began to appear on October 26, when the National Hurricane Center issued this spot in the southern Caribbean you see in yellow as having the potential to develop into a tropical cyclone in the coming days. This system would take quite a bit of time to develop, with confidence reaching a high 70% chance of forming on November 1st. However, that 70% chance was for 5 days out, so Rafael still had a ways to go, or so they thought. Because finally, on the afternoon of November 3rd, a low-pressure center had formed and was designated Potential Tropical Cyclone 18 due to its proximity to Cuba and Jamaica. From this first advisory, soon-to-be Rafael was expected to strengthen into a hurricane before landfall in Cuba, first impacting Jamaica and the Cayman Islands as a tropical storm. From there, the forecast was a bit uncertain, with a 4 to 5 day cone depicting a potential landfall in the central Gulf of Mexico at tropical storm strength. By 4 p.m. on November 4th, Tropical Storm Rafael had officially formed, with the forecast remaining pretty similar to the first set of advisories. Rafael would continue to drift northwestward, passing to the west of Jamaica during the late morning and early afternoon hours of November 5th. But of course, it wouldn't be a 2024 hurricane without a bit of rapid intensification. Over the next 24 hours, between 1 p.m. on the 5th and 1 p.m. on the 6th, Rafael would go from a tropical storm with sustained winds of 60 miles per hour to a Category 3 major hurricane with sustained winds of 115 miles per hour, a 55 mile per hour increase. Notably, the 5-day forecast cone had changed dramatically over this 24-hour period. Initially, Rafael was still forecast to make it up to the Gulf Coast of the United States, but before it even made landfall in Cuba, the storm's forecasted track would shift dramatically, with it looking like the storm would not even make landfall in the US at all anymore. But I'm getting a bit ahead of myself. Rafael would make landfall in western Cuba at 4:15 p.m. as a Category 3 major hurricane with sustained winds reaching 115 miles per hour. Rafael bulldozed over western Cuba before emerging on the other side of the island as a slightly weakened Category 2 hurricane. Again, the forecast models were depicting the hurricane making a sharp left turn before eventually stalling out in the Gulf of Mexico. Rafael managed to maintain its strength for the most part as it slowly trekked across the central Gulf, even briefly hitting a new peak wind speed of 120 miles per hour around midnight on November 8th, making Rafael the second November major Gulf of Mexico hurricane in history. At the same time, the forecast was getting even stranger, with the hurricane expected to make a sharp south-southwestern turn into the Bay of Campeche. However, Rafael would not make it that far as it continued to meander around the central Gulf of Mexico, weakening to a tropical storm by the early morning hours of November 9th. The cyclone would do a bit of a loop in the Gulf, with weak atmospheric steering currents not directing the storm much in any particular direction. Rafael would then dissipate by the afternoon hours of November 10th. Cuba would face significant impacts from Rafael, with the primary hazard being heavy rainfall. Some areas of the island received nearly a foot of rain, which would lead to flooding and landslides in some mountainous areas. In tandem with the rain, strong winds would cause significant electrical blackouts to much of the island, apparently knocking out Cuba's whole power grid. Thankfully, no fatalities were reported from Rafael's landfall in Cuba. However, at least 4 fatalities were reported in Panama due to the predecessor system that would become Rafael. In total, 8 people would die as a result of Rafael across numerous Caribbean islands and territories, and the damage cost is currently estimated to be above $141 million. The 2024 Atlantic hurricane season was extremely impactful, devastating, and surprising in numerous ways, and I'm sure it will be studied for decades to come. I hope y'all enjoyed my analysis of the season, from the preseason forecast all the way through the major storms that lasted well into the end of the season. I know I didn't cover every tropical cyclone that formed in the Atlantic this year, but I feel I covered a majority of the ones that were majorly impactful, or at the very least had something interesting going on with them, and not just in the United States. Initially, the plan for this video was to compare the 2024 hurricane season to other active past hurricane season to give some perspective, but as you can see, this video was already very long and morphed into something else entirely. I intend on making that idea its own video. Think of it as a pseudo follow-up to this one. Anyway, thank you so much for watching. If you enjoyed, please make sure you like and subscribe, as it lets us know that you enjoy what we do here. That's all we have for y'all, and we hope to see you in the next one.